want to tell something about how it works, how lambda takes up the nutrients out of the wastewater. Like Dan already told you, or showed you that lambda is mostly a leaf and a root. The green cells of the lambda, so where the photosynthesis and that kind of reactions take place, is in direct contact with the environment. So that's easy to take up nutrients with the leaf, but they also can take up the nutrients with the roots. So they use both. In case of nitrogen containing molecules, if there is a shortage of, there is two main sources for lambda, which are nitrate and ammonia. If there is a shortage of nitrate, the lambda just takes up less nitrate. But if there is a shortage of ammonia, the ratio changes from mostly leaf nutrient uptake to mostly root nutrient uptake. The uptake ratio from the root will increase from 32% to 73%. So it will get a lot more active, the root. This comes because the root will grow more, and lambda focuses more energy and biomass into the root when there is a depletion of ammonia. So there is a larger absorption area to take up the nutrient, which the ammonia, which is absorbed by diffusion with the carrier protein, which switch the ammonia with protons because they need energy to the protein. The carrier protein needs energy to transport the ammonia, so they take that from the charged protons and unleash the proton into the environment and exchange the proton for the ammonia. It's a mistake. There should be a phosphate instead of sulfate. Uptake also happens that way, like the carrier, which change the phosphate for protons. So fusion with the carrier protein in the cell wall. And lambda can take up a lot of proteins because it has a stabilized tissue. And the protons that are unleashed into the environment, it's convenient for the lambda because then the ammonia will not transform into ammonium. And ammonia is so important for lambda because it helps with the phosphate accumulation. So it builds up phosphate with the enzyme which is catalyzed with ammonia, and that's needed for protein building. Here you can see a bit that it's this is the green cell, and there is in direct contact with the environment. This is one leaf, like it's very thin, so it's easy to transport with the environment, and here you can see a bit how it is with size. Last questions. Which nutrients are mostly lacking? Which nutrients are the most important? For the waste.
For the waste, there's no.
For the compost.
For the compost, yeah. Well. general, yeah.
So we should look broader than only potassium, phosphor and nitrates.
Yeah, basically yes. Yeah, I guess we should consider all the possible nutrients that are necessary.
You know, the potato farmers, they need a compost for the organic matter, and then
What are there any preferred methods for nutrient transfer?
are there any preferred methods for nutrient transfer?
So like a
Yes, the composition of the compost. What's that? Mainly.
I'll have to get
Is it
back
possible
to
to
you.
mix
I
the rest streams in the compost? Like
directly.
Did you try it before or something?
What kind of restrooms?
Like
Wastewater?
Like the chicken manure waste, water and...
No, we haven't tried it.
Other point of rest streams other than landfill? Like if you can do anything without it.
So
It
basically
goes to the landfill.
every rest stream is ending up in a landfill, or there are...
No. No, let me see. No, landfilling is too expensive. Yeah,
waste and
yeah.
recycling.
Yeah. Then we are still left with a waste fraction where we cannot do anything more with it, and our customers don't want it. We have to take it to an incineration plant.
So it's incinerated.
Yeah.
Correct. I think that was